Hello and welcome. Started this video yesterday, and once again my newer camera stopped recording on me and gave me no hint that it had stopped recording on me, so I lost everything I did yesterday. At any rate, I have been needing a new 24-hour clock for the ham Radio Shack. I had an analog one of those 12-inch diameter analog ones that died, and took a look inside and there's not much you can do. It's a blob. But then I saw these. Big Clive just built one of these. He built the one with the green circuit board. These come in a green and black circuit board variant. They are a non-microprocessor control clock. It's got an oscillator, a bunch of dividers, and it's a real simple 1 pulse per second input to the chain clock. And that lends itself very nicely to being controlled by my GPS disciplined oscillator, which is back here. Excuse the handheld work. That guy right there, that is tied to WWV Bureau of Standards via satellite. And these are extremely accurate. In fact, I've got 2 of these so I can do a cross-reference periodically, because the likelihood of 2 of them failing the same is highly unlikely. And I cross-check, and they're accurate to, at 10 megahertz, the 10 megahertz standard output from that is 2/10,000ths of a hertz low. This is the Time Nuts. I don't know if you're familiar with them. Just look up Time Nuts on YouTube. These guys have tested these, several of them, and they're known to have a bug in their software. They are 2/10,000ths of a hertz low in frequency, which means if you multiply it up to 10 gigahertz, you'd be off 2/10ths of a hertz. And if you multiply it up to 100 gigahertz, you'd be off 2 whole hertz. I think that's close enough for the girls I go out with. But anyway, I'm going to use that. I'm going to pull the oscillator chip and just use the input to this flip-flop right here. And that's the one that's controlling our seconds. Now, Big Clive changed all of his to green. These come with red LEDs. I ordered the green LEDs because I like the look of them, but I think I'm going to leave the seconds in red and leave the hours and minutes in green, so at a quick glance you instantly know the hour and seconds. And up here, see if I can get a good view of this. Turn this light away a little bit. And again, let me get the camera up here and start this again. Okay, on the scope here we have the trace from the clock time base, or the 24-hour clock kit time base, I should say, the crystal clock time base. And this is the 1 pulse per second from the GPS disciplined oscillator, or frequency standard, if you will. And while it's considerably shorter, that's not a problem, and the voltage is very close. There's a few tenths of a volt difference, but there's more than enough to trigger the next IC in the chain. So we're going to just remove the 2 chips, the flip-flop and the crystal oscillator chip, and we'll take where pin 1 of the flip-flop, which was its output, that's this trace here, and we're just going to inject our GPSDO into that. And we should have a clock that's very, very, very accurate. And what you're seeing here are the 2 time bases, the 2 GPS oscillators, or GPSDO oscillator units. And I did not line these up. These are triggered in, I'm triggering on this one. This one's free running following this trigger. I did nothing to synchronize these. That is the way they come out of the units, because the satellite is what determines when those pulses occur. It's part of the signal they receive from the satellite, both of the disciplined oscillators, as to when to trigger that 1 pulse per second. and that is synchronized to the National Bureau of Standards in Boulder, Colorado. And if I stop this and just run, I'm not sure, okay, run this up, those overlap perfectly. They're exactly the same time pulse from two independent receivers, two independent antennas, completely independent from each other, but that's controlled by the satellite signal itself. So these two clocks will, when I get them put together, will run perfectly. They'll be synchronized. Alrighty, there we have two of them. The other kit came in and I built it, and again, I didn't bother doing that on camera because Big Clive has got a video building one, and who wants to watch somebody sit there and solder 40 resistors and God knows how many IC pins. But these have been running now for 48 hours, and you can see they're perfectly synchronized. They're running on two completely independent time bases that are satellite based, and they're, you know, absolutely dead in sync. Setting them up, synchronizing them to WWV is super simple. In fact, I can demonstrate that. I've got some USB micro B connectors for the enclosures I'll build for them. I'll put push buttons externally on the case so you can set them from the outside. There's a start-stop switch here that will parallel with these two start-stop switches, and I'll demonstrate that for you in just a second. This kit, Big Clive had no problem with his at all. I had one via where the IC socket plugs in that was blocked, and I cleaned it out and I built the clock, and this segment failed to light. And I thought, you know, the chips, they come in a plastic bag. These one came in a plastic box, and this kit came just in a plastic bag. In fact, that's the bag, and they're CMOS. So I figured, I lost the chip. But I swapped two, and the problem stayed there. So I said, it's a bad display, and I swapped the displays, and the problem stayed there. And then I remembered that via I cleaned out, and I went back, and sure enough, even though the trace looks perfectly intact on the board, it wasn't connected to the resistor here. And so I just put a little piece of wire from the socket of the IC over to the resistor, and in business, just made a little bodge wire on the back. This kit that I built first has 1000 ohm 1K resistors, limiting the current to the LEDs, and they're in a dark room. These are painfully bright. This kit came with 510 ohm resistors. Now the circuits are virtually identical. So I replaced all of the 510 ohm resistors with 1K resistors. There's no reason to push the LEDs that hard, and it's still too bright. But I got a piece of smoked Lexan 1/16 of an inch thick that's going to be a window for these, and it'll tone them down a little bit, and you won't see everything behind it. You'll just see the numerals and the colons blinking. And when we get that built, we'll add that to the end of this video. Very, very, very minor differences. The chips on this one are all horizontal. Over here you've got horizontal and vertical. This board's a little bit wider. And looking at the pins or the hole spacing and everything else, I think I can build the same enclosure, print the same enclosure for both of them, with just an extra set of bosses that won't be used on this one, but I can pick up with the holes on this one. I think they'll fit in together, you know, either way. So it should be a universal enclosure, I'm hoping. I haven't taken a measurement on the exact distance here to here yet, but they look to be the same. What else? I guess that's it. Both of these kits took solder very well. The boards are fairly high quality, and I think that was just a fluke that I got one with a bad via, because Big Clive had no issues at all with his. They take solder well, you know, the pads wet well. They're very small, but if you're If you got a fine tip iron and you're halfway decent at soldering, you'll have no problem building these. These are available on Amazon. They're like $12 or something. They're not expensive at all. Let me turn on WWV here, and we'll demonstrate as soon as the radio turns on. There we go. If you're wondering how difficult it is to set this, I'm going to wait till it comes around to zeros. Now these have been running 48 hours, so you know, I'm not worried about resetting them. And I'm going to wait for this to come up on the minute where this will be 00, and I'm going to flip this switch to stop the clock from counting. The colons will continue to flash because they're bypassed. They bypass this switch. They're driven directly from pin 1. But we'll show you how easy you got to wait for the next minute, but it's not hard to do. So, okay, now I'm going to set this to the next minute. You set up your hours and minutes, and you're ready for the next minute to roll up. In other words, if you were starting out cold and he said 19 hours 35 minutes, you might go 19 hours 37 minutes to give yourself a couple minutes, you know, be ahead of the game. And then you just wait for the on the minute tone and flip the switch, and you're off to the races. So we've got 30, 29, 28, 27 seconds left to go. You can see the countdown over here. Really simple to sync these things up. And that radio over there is in no way tied to this. You're hearing WWV over the air. And when you hear the tone, and you're synced. That's it. It's that simple. Alright, I'm going to get busy designing and printing the enclosures. And actually, setting these up is actually simpler than what I just showed you. Oops, and we go kicking the camera again. Once you've got your second set, you can ignore the hours and the minutes. Just get your seconds synchronized with your local time base. In Canada, it'd be CHU Canada. I'm sure Australia has their own national service for time base. Anybody South Pacific, you can pick up Hawaii WWVU in Hawaii. I think it is VU. I think it's VU in Hawaii. And there we go, kicking the camera again. You can independently set the numbers. It doesn't affect the seconds. So once you've got your seconds synchronized to your local time reference, whatever that may be in your part of the world, then you can just go ahead and set your hours and minutes. It's coming up on 59, so we'll go ahead and set the 59. I'm looking at the top clock because I'm not listening. I don't want to have WWV squawking away in the background. 7, 8, 9, and then 19. See if I can beat it. There we go. And now we'll get the changeover to 20 hours. Bingo. But, you know, get your seconds synchronized, and then you can worry about your hours and minutes later, because they're independent of that. Okay, when we left off, I had built the kits. I have since printed up some enclosures. Now I've got some smoked acrylic over here that will go in behind this window so that all you'll see is the digits and the 2 LEDs. You won't be able to see the circuit board. I changed my mind. I was going to go with a USB connector here and use some old cell phone chargers to power these. But I decided to go with a coaxial power jack. I've got a small industrial 5-volt supply that'll run both of these at the same time with ease. And that means I'm only using up one electrical socket instead of 2. With all the equipment I got down here, sockets are in short supply. But anyway, we've got our start-stop switch. We've got our input for our time base, our minute and hours button, and our electrical connector. The board is simply mounted inside. And we'll wire these up. I won't bore you with it. It's just a matter of connecting these switches to the push buttons and the power to here. And when we get it done, we'll show you what they look like. So I'll get it with it here. Okay, I was about to screw the covers on when it dawned on me I should probably make sure everything works first, in case I have to open it back up. I've got the smoked Lexan installed. All the segments look like they lit up. And looks like it's going to be a little tricky. That switch is going to give me problems. These are out of the junk box. I didn't buy anything. Yeah. Oh boy, I'm going to spray some contact cleaner on those. But that's what it looks like now. The seconds are of course not flashing. Let's see, I can bring the time base down here, I guess. Yeah. Haul that down here. Everything in frame, I hope so. I'm looking at the clock, not at the viewfinder. I should probably, there we go. That'd be the pause and the start. Oh, I don't understand why the colons go dim. That's not normal. Did I do something wrong here? It's working when it runs, but when I put that into the stop mode, that should just open the circuit to the time base. It shouldn't make them dim. Yeah, see, when I turn off the internal one, it doesn't do that. But when I turn this one off, I think I know what's wrong. I'm going to have to inject this into a different place. This is going to have to come back out, because before I was interrupting it with this switch. Now I'm losing everything when I turn it off. I'm losing the input pulse. I'm going to have to see what I can do about that. There's something wrong there. Looks like everything else is okay. Let's check the other one out. I'm looking to see if all the segments work, because the turned pin sockets that they're in are not the greatest. Yeah, this one does the same thing. I don't think it'll hurt anything. Maybe I'll just leave it alone. I don't think it's hurting anything. I think they just go dim because there's no input. And then come back. Yeah, that should be fine. All I'm doing is cutting off the signal source. Let's see what happens when I disconnect this. Oh. Shoot. I didn't tighten that socket down enough. We in frame here? I hope so. If I disconnect the BNC, okay, same thing. It's just loss of signal. It goes dim. It's not going to hurt anything. Alright, I think I'm just going to leave that alone. I'm going to put some more snug on that nut. Maybe a drop of super glue. And I must have forgotten to tighten that nut down. Yeah, that's not going to hurt anything. When I flip this switch, internally it keeps the clock signal going up to the colons. I could probably move this wire over to here and correct that. Alright, let me see what I can do. Let me take a look at this. Alright, I know what's happening, and it's not obvious on the schematic because it's not real clear. This is my 1 pulse per second. It comes out here, goes through S3, and this is the switch, slide switch that's on the board that shuts off the 1 pulse per second to the counter. Okay, I'm reshooting this, or redoing this piece of the video, because when I went back and reviewed what I had recorded, I realized I'd made a real dog's breakfast of trying to explain this. So I've added some lines in here to show you what I've done to run this from the GPSDO. This chip is a 4060 CMOS. It's a ripple carry, binary counter, divider, and oscillator all in one package. And this crystal is divided down for the 1 pulse per second, and then it goes into this flip-flop to trigger the rest of the circuitry. I've removed this chip and I've removed this chip. Neither one of these are needed. This is a dual flip-flop chip, and they're only using 1/2 of it. The other half of it was just sitting there doing nothing anyway. And there's a flip-flop output from the GPSDO, so neither one of these two chips are needed. I'm injecting my 1 pulse per second into where pin 1 was on this CD4013 dual flip-flop. This is the output. Now, the problem was I switched here. I got lazy. When I started this video, I said I was going to parallel this switch with my start-stop switch, and in my haste to get the project done, it went right out of my head and I switched here, which meant we lost the colons. The colons, it doesn't even show them wired here. It looks clearer in the video actually than it does on the paper. I can barely make out what that makes, or what that reads. And it does say 1 hertz there, it says 1 hertz here, and it says 1 hertz here. So in actuality, what they've done is tied the colon LEDs to the output, directly to the output of the flip-flop. That's why when the switch is open and the rest of the clock stops, the colons continue to blink because they're tied directly to this output line, which is now my input line, because this chip is out and this chip is out. So when this switch goes open, which I've now paralleled with my switch, the colons will continue to blink and tell you there's an input present. And as soon as this switch is closed, these 2 digits begin to count. These are your seconds digits, these are your minute digits, and this is your hour digits, and they roll over every 60, so that you get, at 60 it rolls over a minute, at 60 minutes it rolls over an hour, and so on down the line. And I hope that clears. Well, you didn't see the other video. This should be a little clearer than what I initially had done or had said, but I wanted to clear that up and make it clear for anybody. And again, this schematic comes with the green board kit, and it's not nearly that big. I've blown it up. This is what it looks like when it comes with the kit, and I scanned it and blew it up so it's easier to read. But the GPSDO goes into the pin 1 position of where this flip-flop was. That'll keep the colons operating, and when this switch is open, this count here on the seconds will stop. That's how I freeze it and synchronize it. Hope that's a little bit clearer. Alright, that is indeed the issue. Stupid mistake, but we all make them, I guess. If I flip my switch now, my colons continue to blink when it's in the position where I'm waiting for the clock to come up on the hour, or on the minute rather. And then when I flip it, my seconds start counting again. So that solved that problem. I'll do the other one and put them together and get one hung up on the wall. See what it looks like. Okay, once again this camera got me. I went through a whole spiel and it wasn't recording. Sounds like we have a new woodpecker. New Russian woodpecker. I haven't heard any of that over the horizon stuff in a long time. This is on, I'm listening on 10 megahertz right now, the WWV, and it just faded out. There we go, it came back. The 15 megahertz signal is being overwritten by one of those stupid Bible thumpers who gets on there and preaches for hours and hours and hours about God and damnation. Oh, those guys make me crazy. They're so irritating, especially when they park right on top of one of the, you know, time stamp or one of the time frequencies. My other one's mounted over here, or I can do a quick cross-reference. I walk down here. If they're both on the same time, I can be pretty sure that both of my frequency standards are running well. I like the smoked Lexan. You can, if you're right up close and shine a light in there, you can see the board, but as it is now with normal room lighting, you can't see anything but the numerals and the colon. So that worked out well. Nothing I can do with the push buttons. Those cheap Radio Shack push buttons from probably the 1980s. There's no debounce in them, and they're not snap switches. I'm going to have to source something else. Tactile switches or something that, you know, snap on, snap off. Fortunately, it's not too hard to get the frequency set on this thing, so at some point in time I'll pick up some new switches and install them. Just be advised, there's no debounce circuitry in this thing. And now somebody's playing music on WWV. Good grief. What is going on in the world? Well, I shouldn't be surprised with the knucklehead we got running the country. Nobody's got any respect for us anymore. Had to be said. I don't know. 20 wasn't coming in well. I'll try going back to... Yeah, I'll go back to 15 megahertz here. Oh, that isn't it. Frequency input. 1, 5. Oh. Enter. There we go. He stopped transmitting, I guess. A few minutes ago, you couldn't even hear WWV. But it's working well. They're working fine. I can live with these switches for now until I find a decent tactile switch. And I don't think it looks too awful bad up there. So, if you build some of these, make sure you have some good switches. If you're going to run external switches, make sure that if you're going to use an external switch for the time base, you run the time base into the input of the flip-flop, and make sure that you switch it at the output so that the two colons can keep working. I'm the radio mechanic. Hope somebody found this at least mildly entertaining. Haven't made a video in a long time. I've got a lot on my plate right now, but I wanted to get these things done and get them up on the wall. Winter's coming, and be doing some ham radio work. Want to have a good 24-hour clock. Take care. See you soon. Okay, little follow-up. These switches are no good for setting this clock because there's no debounce circuitry on the board, and these are just noisy. I found these and ordered some. These are the same form factor as the normal little toggle switch, same diameter shaft as these push buttons, 1/4 inch diameter, but they're push on. They have a normally open and a normally closed, and they're non-latching. And you can hear them when we get up here by the microphone. They're like a tactile switch type. You know, it snaps on, snaps off, snaps on, snaps off. And the reason that's important is, well, I've got a little test circuit here, but I'm going to show you on the oscilloscope why that's important. Okay. On this trace here, Ignore the other trace, there's nothing on it. There's no probe on that channel at the moment. I'm looking at the output of the switch, and you see it goes on, and then you get this noise, and then it's on again. That was one press. There's another press. Look what happened that time. Every time you see one of these spikes, it's going to advance a digit. That's why when I was trying to set it earlier, it was jumping multiple numbers. And you can see how noisy. There's another button press. There's another button press. They're just horrible. And with no debounce circuitry on the clock board, those just don't work out. Now this new switch that I picked up, I'm going to do a quick button press. There we go. One clean square pulse. That time I think that was me. Connection was bad. Let me try that again. There we go. One button press, another button press, another, and you can see 99% of these are clean. Now I sat here and cycled this for a while. Occasionally I get some switch bounce, and the reason the length is changing so much is just how long I'm holding the button on. If I just press and hold, you can see it stays on. I release, you're not going to see the release because it's triggering on the rise. But if I do a quick button press and another one and another one, and again they're varying because I'm holding it down for varying amounts of time. So that's going to be the cure. These weren't very expensive. You get a half a dozen of them for like $5, and they'll fit in the same hole, and that should eliminate my setting problems. Also, let me turn the scope off so there's not as much background racket going on here. I'm going to move you over here. I picked up another one of these clock modules, and recently, well, I built it last night. Recently, let me zoom back out here. I picked up another one of the black board units, and the reason I bought the black board unit, it's the one with all the 1K resistors. If you buy the green board unit, it comes with 470 ohm resistors, but it also comes with a schematic. So if you want the schematic, buy the unit with the green board. You don't really need it. All the component values are marked on the boards. This has been running for about 24 hours, and it started out about 500 milliseconds behind the other time clock. You can't synchronize this exactly because it's going to depend on where the clock is in its cycle when you turn it on. But I got it as close as I could, and it was about 500 milliseconds behind. Oh, I don't even have you in frame here. It was about 500 milliseconds behind WWV when I set it, and 24 hours later it's about 500 milliseconds ahead of WWV. So you're gaining on this particular board about 1 second per day. Not horrible. I mean, you could probably live with that, and it's going to depend on the board. It's going to depend on these two capacitors loading the crystal. You know, they're disc ceramics, and their values are not very accurate. And that's why I elected to run it off my time base, so I'd have it dead accurate all the time. So, you know, the internal clock on these is going to vary plus or minus about a second a day if you use the crystal oscillator. Okay, going to wrap it up. Thanks for tuning in. And again, if you want to build one of these and put it in an enclosure with remote switches, get some of those snap switches. They're available on Amazon. Again, they're not expensive, and they fit right in the 1/4-inch hole, just like the other unit did. And they're single click, pretty reliable contacts. That's it. I'm the Radio Mechanic. Thanks for coming along, and see you on the next one. Bye-bye.